Okay, so let's talk a little bit about the drawings that we've made, and specifically the lithosphere, which is really the confusing part. So the lithosphere starts at the top of the continental crust. I drew the ocean here or the land, depending, but from the very tippy top of the soil you're standing on to through all of the crust. And then that first layer of mantle, you should have like an orange stripe colored, and then a purple stripe, and then another orange stripe, showing that the mantle has this strange layer within it. So the lithosphere is from the very tippy top of the surface of the Earth through that first orange layer of the mantle. And then that purple asthenosphere is not part of the lithosphere. In the lithosphere, people wonder, well, why would you just randomly assign a name to the crust plus a little piece of the mantle? Does anyone know? Like, why did we have to make it so confusing, Duchesne?
Because that's where the plastic rock is.
Yes. So the next layer that's not part of the lithosphere, right below the lithosphere, is that layer of plastic rock, the asthenosphere. You should have colored that layer purple. And but why do we care about everything that sits on top of the plastic rock? Why do we name that whole chunk of stuff? Chris?
Because it moves.
That. Okay, so next week we're going to talk about tectonic plate theory and how the tectonic plates can shift. You guys know mountains are formed, we think, when two plates rub or collide. And those plates shift because the whole lithosphere is floating on this layer of plastic rock, like a ginormous island. And there are big plates. And the reason that they can shift and move is that they're floating on that layer of plastic rock. So the lithosphere is just everything that's sitting on top of the asthenosphere, because it has the ability to shift and move tiny little bits. So that's why we have that. So now we want to talk about filling in each of the little blocks that you've glued down. So you should have, I don't know where my example is, but you should have a crust here on the first layer that you have. You should have a mantle box, an outer core box, and an inner core box. And we need to fill in some information about the composition, the thickness, and the state of matter for each of those. Or temperature, or I don't. Why do I have thickness written? Did I mean that? Maybe I did. Okay. So yes.
How does the lithosphere moving slightly affect the asthenosphere?
Well, remember we talked about how the asthenosphere is able to. It's under so much pressure and at such a high temperature that even the slightest little jiggle will cause it to solidify in that little spot, right? So when plates are moving around, of course, that is applying those little bits of pressure. So you see when seismic waves pass through, we can see that sometimes it has the properties of a solid and sometimes more of a very thick liquid. Eek.
So when they just name it the lithosphere to...
Everything that floats on that plastic rock is a lithosphere, because that's where we really end up with volcanic and earthquake type activity, is because those plates are able to move because that layer is not solid. It's liquid enough that they can move. So let's talk about the crust first. So you need to fill in the composition of the crust. So I kind of hedged around when we were doing the study guide because I knew we'd get to it here. So what is the crust composed of?
Sediment.
Okay, so rock, silica, which is like sand. Anything else? Sediments. I can't fit the word sediment there.